Problem number 3 has a car going around a curved track, and given some information about the acceleration, we want to determine the time when it starts and from when it starts to when it starts to slip. So starts from rest, 120-foot radius track, increasing speed, and then total acceleration, and then we want to find the time elapsed. Okay, so let's write out what these things tell us. So V1, we'll call it, is equal to 0. This will be our radius of the track, 120 feet. Okay, this increasing speed. So increasing speed gives us our tangential acceleration, 6 feet per second squared. And then total acceleration is 12 feet per second squared. And then we want to find the time. Okay, so if we can find, based on this tangential accelerations, that's the rate of change of speed, given the initial speed is 0, we can find the time if we can find the final speed when we slip. So that's the key. The other key is we need to remember the relationship that the total acceleration is equal to the square root of the tangential acceleration plus the normal acceleration. Okay, when we worked with these types of problems, we had a total acceleration, and we broke that down in the tangential component, which is change in speed, and the normal component, which is related to the direction change. And then, of course, the other thing to remember is the a sub n is related to the velocity by v squared over the radius of the curvature. Alright, so this velocity, this is our final, or our velocity 2, that's going to let us find that. Okay, so we're going to plug this into there. We know that number, we know that number, we know r, so we can find the velocity. Alright, so I'm going to have 12, everything's in feet per second squared, so I won't write units out. We'll just work with this. So 12 is equal to 6 squared. Okay, be careful here because this is V2 squared over 120, but that whole quantity's squared. Okay. So I'll use my calculator to solve for V2. And I'll just go ahead and use the solver, even though this one's not too bad. Alright, so I'm going to have minus 12 plus square root 6 squared plus, I'll just go ahead and put this in a quantity, x squared divided by 120, quantity squared, and then that will end my square root, and we'll get 20 as initial, solve for that, and get 35.3. So that tells me that it starts to slip when my velocity is 35.31 feet per second. Okay, so I'll come over here and I'll have V2 is equal to V1 plus the tangential acceleration times time. Solving for time, just have 35.31 feet per second divided by tangential acceleration, so that's just the 6 feet per second squared. Alright, so I'll just have, in my case, x divided by 6, 5.89 seconds. Key points for this equation right here: the relationship between total, tangential, and normal acceleration. formula for normal acceleration, and then being able to use this to get the time based on the velocity and the acceleration.